Hello students, welcome to aimsindia online classes. This is a chemistry session. In this, we are discussing about the chapter atomic structure. In this session, we are going to see the introduction part of this atomic structure. Actually, about this chapter already we have seen in the earlier classes. So we are going to see the recapitulation along with introduction. We have learned that atoms are the fundamental building blocks of every matter, isn't it? In the earlier classes also, we have seen about this. Atoms are the fundamental material particles, fundamental building blocks of every matter, whatever the matter you choose. So it is made up of very tiny particles which are called atoms. So whatever the matter you take, all the matter, there will be atoms. These atoms only combining together to form all these matters. In 600 BC, Indian philosopher and saint Maharshi Kannad came forward with the idea that matter is not continuous and made up of tiny particles named Paramanus. Yes, Maharshi Kannad in 600 BC itself, he told that every matter is made up of small particles called Paramanus. He told that every matter is not continuous, it is made up of small particles. It is not being continuous. It is composed of so many small and tiny particles. He called those tiny particles as paramanus. He further said that two or more paramanus combine to form bigger particles called anus. So these paramanus and anus we are calling nowadays as atoms and molecules. So to say, in our words, Maharshi Kannada told that every matter is not being continuous. So matter is made up of very tiny particles called atoms. These atoms are one or two, they are combining together to form a bigger particles which are called molecules. So these molecules, so many they are composing together to form the matter. The same he told in Sanskrit as every padartha is made up of particles called anus. These anus are composed of paramanus. So in earlier days itself, our saints they came to know about the matter. So they told matter is not being continuous. It is made up of tiny particles called anus and these paramanus. Okay, it was told in the 600 BC itself, very early. Later, around in 400 BC, after 200 years almost, Greek philosopher Democritus proposed that all matter is composed of tiny discrete individual particles that he called atoms. So the same concept which was already proposed by Maharshi Kannad in 600 BC. After 200 years, the same concept was explained and proposed by one more philosopher from Greek. He was Democritus. He proposed that all the same again. All matter is composed of tiny, discrete, and indivisible particles that he called as atoms. The meaning of this word atom is itself indivisible. So the matter, if you take a small matter, you break into small pieces, and if you get a small piece, again you can break it. If you continue like that, at last we get a smallest particle which cannot be further divided. Those particles they call as atoms. Atom, the meaning itself, indivisible. So his ideas based entirely on philosophical speculation rather than experimental evidence. So actually, Democritus he proposed that this matter is made up of small particles called atoms, and these atoms are combining together, forming molecules and matter further. But there are no experimental evidences for these proposals. These are completely philosophical speculations. But later, experiments have shown that atoms are composed of three principal kinds of subatomic particles. Yes, later some experiments they have shown and proved that atoms are not the smallest particles. Atoms they contain still smaller particles which are called as subatomic particles. As we have studied in the earlier classes about these. What are those subatomic particles? Electrons, protons, neutrons, neutrinos, positrons. There are nearly 100 types of subatomic particles. There are 100 types of smaller particles still than atom, which are present inside the atom. These all are called subatomic particles. Out of these, the very important and stable particles are electrons, protons, and neutrons. That is why these three are specially called as fundamental particles also. Anyhow, these electrons, protons, neutrons are present inside the atom, so atoms are no more smaller particles. The theory or proposal given by Democritus, Maharshi Kanad were kept wrong because they told atoms are the smallest. But later on, experimentally, they have discovered these electrons, protons, neutrons, which are there inside the atom. So atoms are no more smaller. Electrons, protons, neutrons. At the center of the atom, there exists a very tiny, extremely dense core called nucleus. Yes, at the center of the atom, there is a dense, smallest dense part. That part is called nucleus. In this nucleus, these positive protons and neutrons are accumulated. That part is called nucleus. It is the densest part of the atom. And these electrons are surrounding this nucleus and fill the remaining volume of the complete atom. So the remaining part is almost hollow. Only electrons are revolving around this nucleus. In the nucleus itself, these protons and neutrons massive particles are concentrated. So nucleus is the densest part of the total atom. Remaining part is hollow. In that hollow space, electrons are filled around the nucleus. Okay. Let us say about this some more about these subatomic particles. First among them is the discovered electrons. Electrons were discovered by J. Thompson. These all we have studied how they have discovered by using these discharge tube experiments. So J. Thompson discovered these electrons. These are negatively charged particles. Actually, here it should be into. So electrons are negatively charged particles. Their charge quantitatively it is given as minus 1.602 into 10 to the power of minus 19 coulombs. And their mass is very negligible. Very minute mass is they are having. So quantitatively the mass of the electrons is taken as 9.11 into 10 to the power of minus 28 grams. That's the mass of electrons. Next, one more kind of subatomic particles, they are protons. So protons and electrons both are having same quantity of charge, but opposite in charge. Electrons are having negative charge, protons are having positive charge. So the how many number of electrons are there in an atom, the same number of protons also will be there. That is why atoms are being generally neutral. Positive charge is being cancelled or balanced by the negative charge of electrons. So the quantity of charge of electrons and protons is same, but they are in opposite signs. So protons are having positive charge and it is equal to 1.602 into 10 to the power of minus 19 coulombs. And the mass of protons is considered as 1 AMU, which is also called atomic mass unit. It is the smallest unit of mass. Actually, the mass of electrons is still smaller, but it is negligible, we can say, when compared to the mass of proton. So, it is considered the mass of proton as one standard unit, smallest unit of mass. It is called 1 AMU, which is equal to 1.67 into 10 to the power of minus 24 grams. It is the mass of one proton, which is also considered as 1 AMU. AMU represents atomic mass unit. Okay, next subatomic particle, neutron. Neutron is one of the subatomic particles with no charge. Neutrons are having no charge. They are chargeless particles and their mass is almost equal to the mass of protons. So in mass, protons and neutrons are having same mass. By coming to charge, electrons and protons are having the same quantity of charge but in opposite charges. Okay, neutrons are having no charge, chargeless particles. and their mass is equal to 1 AMU approximately. That is 1.67 into 10 to the power of minus 24 grams. That's the mass of neutron. Protons and neutrons present in the nucleus and the electrons occupy the bulk of the space with their moment around the nucleus. Yes, protons and neutrons are concentrated at the center part, very small part. In this total small part only, these total protons and neutrons are concentrated. The mass or the size of the nucleus is very small when compared to the total size of the atom. In the small part only, protons and neutrons are being together in an atom. The small part is called nucleus. Now, around this nucleus, electrons are revolving around the nucleus in the remaining space. So, in that way, atoms are constructed by the subatomic particles, electrons, protons, and neutrons. So here protons and neutrons are at the center. So they are called nucleons also. Okay, nucleons. Now let us see different atomic models proposed by different scientists. Atomic models. As we have seen, there are three kinds of subatomic particles in the atoms. They have discovered these subatomic particles present in the atom. As these particles are there, they came to know how these particles are arranged inside the atoms. So they have proposed different models. Let us see one by one those. First among them is Dalton's model of the atom. John Dalton proposed that all matter is composed of very small things which he called as atoms. Just like Democritus how he told. In the same way, John Dalton also proposed the same time all the matter is composed of very small things which he called as atoms. As we told, the name atom is derived from the Greek word which means indivisible, atomos. It means indivisible. So he called the smallest particles of matter as indivisible particles or atoms. Of course, this was not a completely new concept as we told. This was not a completely new concept. As earlier the scientists, ancient Greek scientists, they proposed that all matter is composed of small indivisible objects, isn't it? Democritus already in 400 BC itself he proposed that every matter is composed of small indivisible objects. The same concepts again he rose here with his proposals. It is to be noted here one more point. When Dalton proposed his model, electrons and the nucleus were unknown. Till then, they didn't come to know about these subatomic particles. While John Dalton proposing this theory, they don't know about the particles present inside the atom. They have come to an idea that atoms are the smallest particles of every matter. That is why the name atom is given for those particles. Atom itself it is denoting indivisible. They don't know about these electrons for neutrons, protons further. Later on they came to know. Now Thompson's model of the atom. Next model is J. Thompson's atomic model. While he was giving this model, they came to know as atoms are containing electrons. These electrons, in fact, they were discovered by J. Thompson itself. By his discharged experiment, he found those. And they came to know as there is positive mass also inside the atom. Now, based upon these two, he has given a model. He assumed a model. In 1904, J. Thomson proposed his famous plum pudding model because he compared the atomic structure with the plum pudding fruits. According to him, an atom consists of positively charged sphere with electrons embedded in it. Yes, what he considered atoms are spherical in shape and they contain completely positive mass. And electrons are embedded in this positive mass and the whole mass. An atom as a whole is electrically neutral because the negative and positive charges are equal in magnitude. Yes, he told that further atoms are being electrically neutral because these atoms are having positive charge and negatively charged electrons. The quantity of this positive charge and negative charges being equal, so they counterbalance one to another, and hence finally atoms are being neutral. Thomson's atomic model is compared to watermelon. Yes, he compared the model of the atom with some plum pudding fruits like watermelon, apples, and plums, where he considered watermelon seeds as negatively charged particles. See, if you cut a watermelon to the middle, if you observe, there will be completely red pulp inside the watermelon. So the red part of the watermelon he considered as positive mass of the atom. And we can see the black seeds embedded inside the watermelon in the whole mass. So he compared these black seeds with the electrons, or he compared electrons with these black seeds. In this way, he compared his model of atom with watermelon. That is why his model is also famous in the name of watermelon model, or plum pudding model, or apple pie model. So these are because he compared the model of the atom with these different fruits. The total mass of the uh, like watermelon, the red pulp, how red pulp is spread over in the watermelon. In the same way, positive mass also spread over in the atom. And how black seeds are embodied in the red pulp in the watermelon, in the same way, electrons are also embodied in the positive mass in the entire total space in the atom. And the total electric charge of the electrons, negative charge of electrons is counterbalanced by total positive charge in the atom. Hence, atoms are being neutral. So they are the proposals given by J. Thomson. Next, one more model was given by Rutherford, as there are some drawbacks or limitations in the J. Thomson's model. So that was Rutherford's atomic model. Rutherford, for explaining about the atomic structure or the model of the atom, he did some experiment on the atoms to identify how the particles are arranged inside the atom. He did an experiment which is famous with the name all-for-a scattering experiment, which is also known as Rutherford's gold foil experiment. So by these observations came from this experiment, he concluded one model of atom. So let us see first about that experiment. Rutherford, a student of J. Thomson, modified the atomic structure with the discovery of nucleus. Yes, he was the first scientist who to know about the nucleus of the atom. His atomic model is based on the all-for-a scattering experiment. We know all-for-a means where the particles are a bunch of two protons or two neutrons is called an alpha ray. Generally, these alpha ray particles are emitted from some radioactive substances like radium, uranium. These they produce these alpha particles. So, for his experiment, he's taken a sample or source of alpha particles like radium sample he had taken, as it is a radioactive substance which is a dangerous substance, as it is emitting harmful radiations. It is kept in a closed lead chamber, and which is having only one outlet. Only through this outlet only these alpha particles will come out now. And he made these alpha particles to fall or to strike a very thin gold foil. How thick? How much thick means around 0.00004 mm. This much thick gold file he has taken. Very thin gold file he has chosen, almost a frame of atoms. And he took that gold file and he made these alpha particles to fall on this gold file. And to observe what is happening after falling on the gold file to these alpha particles, he surrounded this gold foil with a zinc sulfide screen. Then he started observing the symptoms, scintillations on the zinc sulfide screen. So he passed the beam of alpha particles to the thin gold foil to observe the atom and noted how the alpha particles are scattered from the foil. So he observed those points there. So just he has taken some radioactive substance like radium he kept that radioactive substance in a closed lead chamber, which is having only one outlet. Through that, these alpha particles will come out now. Alpha particles nothing but He plus 2 ions, simply to say. We know helium atoms contain 2 electrons, 2 protons and 2 neutrons. When these 2 electrons are removed, then it becomes a composite of 2 protons and 2 neutrons. Symbolically, it can be represented like this: He plus 2, or alpha particles. Okay, these are generally cannot be prepared from helium atom, because helium is one of the smallest atoms and it is a high ionization energy. So these alpha particles are created or generated or produced from radioactive substances. That is why a source of radio or alpha particles is taken here, radium. And these alpha particles coming from that are made to fall on the very thin gold foil. And then by keeping a screen around the gold foil, he observed what is happening, how these alpha particles are moving through the gold foil. Let us see here the observations from this experiment. Most of the rays just went through the gold foil, making scintillations on the zinc sulfide screen. See, suppose this is a gold foil from here to here. Very thin gold foil he has taken. This is the gold foil. Now alpha particles are coming and striking this. Then he observed that most of the alpha particles, they are directly passing through the gold foil and falling on the zinc sulfide screen back to it, making scintillations here after striking the gold foil. Some flash is coming. From that he observed most of the alpha particles are directly passing through the gold foil without any disturbance and deviation. Next observation, a few rays got reflected after hitting the gold foil. So some of the rays, see here, after hitting the gold foil, just they're deflected from their path like this, a little deviation. Instead of falling here, they're made to some scintillations a little side. Means some of the rays are reflected by hitting the gold foil. One more observation, 1 out of 1000 rays means very less number of rays. They're reflected by an angle of 180 degrees after hitting the gold foil. Means very few of the alpha particles after hitting the gold foil, they are bounced back to their path with an 180 degrees angle. Just exactly coming back to their path after hitting the gold foil. So these are the observations done by Rutherford in his experiment called alpha ray scattering experiment or gold foil experiment. Okay, by based upon these observations, he given a model called Rutherford's alpha atomic model. He told that atoms are spherical and protons and neutrons are completely concentrated in the very small part of the atom at the center, which is called nucleus. Around these, electrons are revolving in different fixed paths called orbits. So he called the center part of the atom as nucleus. The term nucleus was first used by him. He discovered the nucleus. Okay, so and he compared this model of atom with the solar system, how sun is being at the center of the solar system. In the same way, in an atom also, the nucleus is being at the center, and how these planets are revolving around the sun in different fixed paths called orbits. In the same way, these electrons are also revolving around the nucleus in these imaginary fixed paths called orbits. So his model is also called as solar system model or planetary model. Okay, there are different atomic models given by scientists. Thank you for watching our video. Please subscribe our YouTube channel Aims Today for latest updates and recorded videos.